Hello everyone. We have already completed the that is the there is various factors which will affect the terminal voltage of an alternator. Means there are mainly three things. First one is the armature resistance, second one is the armature reactance, and third one is the armature reactance. Here now we have to concentrate the another new topic. It is known as voltage regulation. Clear? So what do you understand this voltage regulation? The voltage regulation is nothing but the difference between the generated voltage and the terminal voltage of the alternator. Clear? So a convenient way to compare the voltage behavior of two generators is by their voltage regulation. The VR of a synchronous generator at given load, power factor, and at rated speed is defined as the VR is equals to VNL minus VFL by VFL into 100. Okay, that is the percentage of voltage regulation. We are defining voltage regulation in terms of VR, capital V suffix R. Here, that is defined as VR voltage regulation, where this VFL is the full load terminal voltage. When you are having the full load, that is the maximum current will be flowing through the alternator is known as VFL, and VEF or ENL is stands for NL means no load. ENL or EF is not denoted as no load voltage of an alternator. That is when there is no load, or we can consider it as a open circuit here at the rated speed, and the load is removed without changing the field current. For lagging power factor, VR is fairly positive or unity power factor. For unity power factor, VR is small positive, but for lagging power factor, VR is negative. Clear? So when this all, because already we have understand that the various factors, that is the terminal voltage of the alternator will mostly depends on the armature reaction, because if the temperature is constant, so more or less the internal resistance of the alternator as well as the armature reaction RA and XA is almost constant. But so this VFL at full load voltage, so try to understand when you are having no load, means the terminal means the generated EMF and the terminal voltage will almost be same, and or the that will be, that is your VR is positive, because everything the armature reaction will depends on the power factor, and if the and depending upon the power factor also the voltage regulation changes. Clear? That is for a lagging power factor or unity power factor, that VR is positive, but for the capacitive load, that is for the capacitive load, when the power factor is leading, that's why VR is negative. This all we can conclude from the armature reaction part. We already know for the inductor, that is the lagging power factor, it has a demagnetizing and cross magnetizing effect. But for the capacitive load, it has magnetizing effect. That's why the terminal voltage, that is VFL, will be greater than the generated voltage. Then the VR will be negative. Here. So now, what is the way of voltage regulation? It's a very important thing is synchronous impedance method. To find the voltage regulation, we need these three data, because already we have understand that these three are the factors which will affect the terminal voltage, that is armature resistance, open circuit characteristics, and short circuit characteristics. These three things we need to measure to calculate the voltage regulation, because obviously armature resistance we need to know, that is Ra, and next one is the open circuit characteristics, means open circuit characteristics. So we can assume that the generated EMF will almost be equal with the load EMF, load terminal voltage. That's why open circuit characteristics. And short circuit characteristics means when we are having the maximum load current in the alternator terminal. That is your short circuit characteristic. So how to find the resistance of an alternator? It's a very simple way. The resistance of an armature or the stator winding per phase can be determined by using a voltmeter or ammeter method, by using the Wheatstone bridge also. The effective stator winding resistance is always better than the DC value of the skin effect. The AC resistance may be taken approximately 1.2 to 1.3 times the DC resistance measured. Clear? So simple, we already know V equals to IR. So from there, R equals to V by I. We can easily measure the amount of volt resistance. Clear? Just we are measuring V equals to V and I. So R equals to V by I. Clear? Next one is the open circuit test. The generator is turned at the rated speed. The terminals are disconnected from all loads and the field current is set to 0. Then the field current is gradually increased in step and the terminal voltage is measured at each step along the way. It is thus possible to obtain an open circuit characteristics of a generator. Okay, that is here we are just opening the terminal. So the almost the terminal voltage will be equal to the generated EMF. Okay. Okay. So almost so that we can understand, that is the terminal voltage is equal to the load voltage. So from here we can understand the open circuit characteristics. Now the next one is short circuit characteristics. So we can measure the maximum current which will flow through the short circuit terminal. That is, adjust the field current to 0, short circuit the terminals of the generator through the set of ammeters, record the armature current ISC and the field current is increased. Such plot is called short circuit characteristics. Means we are slowly increasing the voltage and the generated voltage will increase as well as the load current will increase. From there we can measure the short circuit characteristics. Those things already performed in the laboratory experiment. And the last one is the determination of excess so that we can measure the voltage regulation. Okay. For a particular field current, the internal voltage could be found from the open circuit characteristics and the short circuit characteristics flow. Means from here we can measure those things. And then the synchronous reactance could be, we have this very simple, that we can measure the total reactance and already armature resistance is measured. So from there we can directly measure the synchronous reactance. So again, it's a repetition, that is the synchronous reactance is a very important topic, which is the total reactance of the circuit. That is the armature reactance, that is the armature reactance and the armature reaction reactance. Clear? So that these two known as synchronous reactance. Try to understand the summation of armature reaction reactance and armature reactance. Clear? Armature reactance, that is XA, and armature reaction reactance, that is XAR, is totally known as synchronous reactance XS. Okay, so that is the end of your voltage regulation.